Pipe supports. 100% you will be familiar in supports after fully watching this video. Keep in touch with us. Introduction. Pipe supports. Pipe support definition, application, scope. Pipe support definition. Pipe support engineering is a field of engineering to support the pipes and pipelines in power plants, process plants, and utility systems. Pipe support application to reduce pipe sag, longitudinal pipe stress, to transfer system weight, to reduce the endpoint reaction loads, to reduce the effect of slug forces, occasional loads, earthquake wind forces, to maintain system flexibility, to accommodate thermal movement, to avoid flange leakage, fatigue failure, to avoid damage to equipment. Scope based on the criticality of the line, stress critical lines, logical support location to be given to piping stress engineer, final number, location and type of supports to be done as per stress engineer's recommendation. Non-critical lines, support location, number of supports, guide location to be placed as per standard support and guide spans given in piping support standard by design group. Classification of pipe supports. Primary and secondary supports, hot and cold pipe supports, support types based on the function, restraints, anchors, stops, anchors, special pipe supports. Primary supports. Primary supports that are directly welded to or in contact with pipe, hanger and support to sustain the dead weight of the piping system. Types: rigid hanger, spring hanger, variable, constant, shoe trunnions. Restraint to restrict the movement due to thermal dynamic loading. Types: anchor, guide, limit stops, hook clamps, studs. Vibration absorbers to restrict the movement due to vibration caused by wind, earthquake, fluid flow. Types: snubbers, sway brace, hold down. Hangers and support. Hangers supports are used to carry the dead weight of the piping system along with its content. The primary difference between a hanger and a support is that the hanger sustains the dead weight in tension, while the support sustains it in compression. Consequently, hanger supports the piping system from top, while supports are placed below the piping. The type of support hanger assemblies from which the piping engineer selects the appropriate kind of support are generally classified as follows: rigid hangers, shoes, trunnion, flexible hangers, variable and constant. Hangers and support. Rigid hanger. Rigid hangers are normally used at locations where no vertical movement of the pipe occurs. The design consideration for a rigid hanger or pipe temperature for selection of pipe clamp material and the load for the selection of component suitable for the pipe weight involved. Although these hangers prevent vertical movement of the piping system in many cases, they allow little horizontal movement at the point of the attachment such that the inclination from the vertical direction is limited to 4 degrees. The compressive force imposed and the anchor due to thermal expansion of piping needs to be controlled to avoid buckling of the anchor rod. The main advantage of rigid anchors over shoe trunnion is that it does not provide any frictional resistance for thermal growth. However, it is expensive and it does not dampen the vibration. Hanger support rigid anchor, constant weight anchor. In this type of support, weight of the piping contents is balanced by a counterweight. To reduce the size of counterweight, it is often the practice to apply the principles of pulley or lever or fulcrum mechanism as shown in figure. When the piping system moves up down due to thermal growth, the balancing force on the piping remains constant. Hence, this is advantageous over rigid anchor where lift off is restricted. However, these anchors require the entire support to be larger since either the counterweight should be heavier or the pulley lever fulcrum should be larger, requiring more space as the bearing load increases. Hanger and support shoes. Shoes. Shoes are commonly used for carrying weight of the piping contents where the piping system is insulated to prevent heat loss. Shoes have the advantage of occupying less space than the rigid anchors. However, they provide friction against the horizontal movement which may be reduced by the use of rollers or slide plate assemblies. While using shoes, care has to be taken that pipe is not lifting off from rest position due to thermal expansion, in which case supporting function is not achieved at all. Shoes are generally of two types based on the type of insulation: hot insulation, cold conservation insulation. Hangers and supports trunnions. Trunnion. Trunnion or dummy supports are generally used in vertical run as well as when the clearance between the BOP and grade is higher. Dummy supports are suitable for supporting a piping system from an elbow. While using dummy supports, care has to be taken that pipe is not lifting off from its rest position due to thermal expansion, in which case supporting function is not achieved at all. It is recommended to check the local stress at support location as well as strength of the dummy pipe. Hanger and support. Flexible anchors. Flexible anchor. When the piping system moves up or down due to thermal expansion, conventional rigid support is not feasible as it may not take load at all or it may act as pivot. Under such condition, it is recommended to use flexible support such as spring anchors. These spring anchors sustain the primary load by their resistance against compression while allowing for free thermal expansion. Flexible anchors are two types: variable spring anchors, constant spring anchors. Variable spring anchor. This is used to support the piping subjected to vertical movement where constant supports are not required. The inherent characteristic of variable spring anchor is that its supporting force varies with the spring deflection as explained here. Anchor supports variable spring anchors type A. This arrangement is useful when the headroom clearance available is more. The type B. This arrangement is normally used when the headroom clearance available is not higher. Type C, identical to Type B except that a lug steel attachment will take a lesser load than that of Type B. Type D, normally used whether headroom clearance available is too less to accommodate can. Load adjustment is done from the top with the help of adjusting nut. Type E, identical to Type D except that adjustment is done from below using turnbuckle but also can be done from above the piping. Type F, designed to support piping from a base below or from the bottom, the base flange being fastened to the floor or to the supporting beams. This is not to be used for excessive horizontal movement. Type G, made up of two standard spring units welded to the end of a single or pair of channels, suitable for excess load or low headroom clearance. Each spring is carrying one half of the total load. Hanger and support constant effort spring. Constant effort hanger provide constant supporting force in both cold and operating conditions. When piping stresses and reaction are known to be close to allowable, most economical type of flexible support is constant support hanger. For critical high temperature piping and hanger location where the vertical movement of piping is high or the variation in support force is to be controlled within 6% constant effort hangers are recommended. Restraint guides. Guides are generally used to restrain the pipe in the lateral direction, allowing the pipes to expand axially. Limit stops. Axial limit stops are used to restrain the pipes in the axial direction, thus allowing movement in the lateral direction. Anchors. An anchor is a mechanical connection between a pipe and a structure. The structure must be strong enough so that it cannot be bent excessively under large forces. Anchors don't allow the movement or rotation of support point and completely fix the line in its place. Equipment nozzles are also anchors. U-clamp. It is acting as guide anchor as per the installation, normally used in small bore piping. Sway stud assemblies. Sway stud are used to restrain movement of piping in one direction while providing for movement due to thermal expansion or contraction in another direction. Vibration absorbers, snubbers. The requirement of snubber is to provide little resistance to the movement associated with the thermal expansion of the piping, while providing stiff supporting reaction against the vibratory motion associated with dynamic loading such as earthquake load. Snubber goes to restrain mode based on a particular velocity or acceleration of motion depending on its design concept and its known as activation level. Typically, snubbers are located where large concentrated load such as valves, large components, flanges, and other components that are not anchored. Changes in piping direction within long vertical rises on long straight pipeline. Snubbers are basically of two types: hydraulic snubbers, mechanical snubbers. Vibration observers, sweep brace application, controlling vibration, observing shock loading, guiding or restraining the movement of pipe resulting from the thermal expansion, bracing a pipeline against sway. Spring washers, pulsation line support. Special support restraints are used for pulsation line. Hold-on supports using spring washers are mostly used. Primary support wear pad. Wear pad used on lines subjected to wear causing reduction in pipe wall thickness. Wear could be caused due to one of the following reasons: corrosion at contact surface between pipe and support structure, high load acting on the pipe, large bore within vault pipes are subjected to wear due to high vertical and friction loads. Wear pad shall be cut from parent pipe at site during pipe fabrication. Cold insulated line supports. Lines subjected to cold conservation insulation cryogenic services. Cold pipe supports are used to prevent the extreme temperatures from affecting concrete or steel structure of the pipe support. From process perspective, the need to insulate piping from exposure to ambient temperature is of paramount importance for the viability of the process. Localized disruption in insulation for supporting purpose can result in very high cost and disruption in process. Types of cold insulation supports used: thermally Micarta, high density polyurethane foam, glass reinforced epoxy resin, densified wood. Design of cold support is vendor specific, though specific requests upon design can be given as to the type of insulation, compaction, etc. for cost control. Cold insulated line supports cold shoes. Provides rest supporting for the cold insulated lines. Layering depends on the amount of insulation required. Cold insulated line supports cold axial stops. Construction is similar to cold shoes. Axial thrust rings are used for providing the anchor support as desired. Design and construction varies from vendor to vendor. Secondary support. Secondary supports are piping civil structure that transfer the load of the piping system to foundation load carrying member. Secondary supports are designed by piping civil based on the type of structure, magnitude, and direction of the load acting on the structure, distance of the pipe support from the load carrying member. Piping support are as defined in the piping support standard. For civil design support, piping loads are to be transferred to civil. Secondary support civil design structure. We have two types of civil design structure based on the material of construction: RCC structure, steel structure. For a single pipe support, we use primary steel, secondary steel, special supports, foundation pedestal. For a group pipe support, we use pipe rack, sleeper, pipe rack, pipe corridor, pipe trussel. Secondary support civil design structure, foundation pedestal. Pipe support pedestal is a small concrete pedestal having insert plate on top. It is especially designed and cast for pipe support by civil. Pedestal design loads in insert plate size are given by piping to civil. Insert plate is normally a square type and the size is designed to accommodate any feature based guide that may be required in that support. Anchor fastener base plate. Anchor fastener base plates are fixed on the finished concrete surface by means of anchor bolts. Bottom of plate and top of concrete will be in same elevation. Difference in elevation will be equal to the plate thickness. This is limited to small pipe support loads due to cost impact and limited load carrying capacity. Pipe sleepers. Sleepers are used where the pipes are running along the grade level approximately at 1 meter elevation. It is a rectangular shaped concrete pedestal having insert plate on top and supporting more than one pipe. Distance between sleepers is usually equal to the minimum pipe span required in the group of pipes. Depth of sleepers is normally 100 to 150 mm and the length of sleeper will depend upon the number of lines running on it. Edge of sleeper shall be minimum 50 mm from the body of pipe. Steel structure. Special support structure. Primary steel structure. Secondary steel structure. Pipe rack structure. Pipe bend structure. Pipe trestle. Pipe corridor. Pipe support span. Typically, piping is supported at regular intervals on steel supports embedded in concrete foundation or directly on steel structure. The distance between supports is the span. Pipe support span factors. There are four main factors which affects the support span: stress, deflection, natural frequency, allowable loads. By relating natural frequency and deflection limitation, the allowable span can be determined as the minimum of the calculated support spacing based on stress and deflection. Pipe span for different piping configuration. Piping loads type: sustained load, self weight of pipe and fitting in position. Design load, load due to design condition of fluid, example pressure, temperature condition. Operating load, load due to operating condition of fluid. Occasional load, load due to seismic, cyclone and wind. While designing support, we need to consider the maximum of these loads, though occasional loads are considered on case-to-case basis. Blast load on piping support to be designed as per the client specification. Piping loads, load vector, resolution of piping loads. Vertical load, compressive load is the self-weight of piping and operational load which acts downward direction. Horizontal loads are two types: a lateral load, biaxial load. Horizontal loads are creates rotational and movements on pipe support steel. Selection of piping supports. Common points to remember. Things to check before selecting a support: material of parent pipe, equipment connected to the piping, type of secondary steel available, configuration on the piping system, type of insulation of the piping system, type of process fluid phase of the piping system, availability of steel based on procurement, client requirement specification. Selection of piping supports. SS bearing plate shall be welded to supporting steel when SS this pipe are directly resting on steel. For SS and DSS pipes and CS pipes requiring PWHT, clamp type support shall be used to avoid welding. Also for SS DSS pipe, SS sheet shall be inserted between the pipe and the clamp. Shoe shall be used based on the insulation used on pipes. For uninsulated or PP insulated pipe, no shoe is required. For HC or CC insulated lines, shoe is required. Before selecting the shoes, the axial displacement of piping has to be taken into account. In case pipes are running on rack, an axial displacement of the pipe at support location is very high. Then it has to be checked whether shoe length provided is sufficient. Slope lines should be tested using shoe supports only. Guide shall be normally placed with a gap of 3 mm. In case of gaps other than 3 mm as required from stress analysis, note shall be clearly mentioned and isometric drawing. Selection of piping support continued. Hold down support to be avoided as much as possible. In case hold down support is required, it can be achieved using U-bolts, hold down type shoe guide arrangement. Positive vertical load to be kept as minimum as possible, or spring shall be used in case it is not possible to lower the positive load on the support. Use of dummy leg support to be minimized to avoid stress concentration points in the parent pipe. Use a pipe up support to be minimized as much as possible, though it helps in supporting small bore lines and avoiding use of large quantities of steel for the same. Standard piping support to be used as much as possible. Use of civil support pipe support is based on the cost factor from design and construction point of view. 10 do's in design of pipe supports. The following leads to good engineering practice. Use minimum number of supports. Limit the use of flexible supports. Provide supports near the already provided columns and beams. Provide necessary clearance for thermal movement. Consider all the primary, secondary, and vocational loads in the design. Provide access for valves and fittings. Provide optimum loops to satisfy flexibility requirements. Provide guide to resist occasional loads like wind and earthquake. Provide an ergonomically acceptable design. Provide support for vents, drain, startup vents, and silencers. 10 don'ts in design of pipe supports. Avoid the following in design. Avoid too many anchors. Avoid too long a span. Avoid too thin a pipe. Avoid large local stresses. Avoid too many fittings. Avoid too many flexible supports. Avoid supports on horizontal bends. Avoid supports on pipes inclined to the vertical. Avoid bunching of too many pipes. Avoid large vertical or horizontal loops. Codes and Standards for Piping Design MSS Standards MSS SP 58 Pipe Hanger and Supports Material Design and Manufacture MSS SP 69 Pipe Hangers and Supports Selection and Application MSS SP 89 Pipe Hanger and Supports Fabrication and Installation Practices MSS SP 90 Pipe Hanger and Support Guidance on Terminology British Standard BS 3974 Part 1 1974 Specification for Pipe Supports Part 1 Pipe Hanger, Slider and Roller Type Supports BS 3974 Part 2 1978 Specification for Pipe Supports Part 2 Pipe Clamps, Cages and Cantilevers BS 1726 Part 1 1964 Guide to the Design Specification of Coil Spring BS 970 Part 5 1972 Carbon and alloy steels for the manufacture of hot form spring. Thank you. Keep in touch with us. Comment below, like, share with your friends.